Science, science, science. In. Pajamas. Alright, guys, welcome back. Today we're going to talk about growth types. So we're going to look at the two more common types of um, growth patterns that we see in populations. Now, this shouldn't take too long. Like I said, there's only two, and we're going to get through them pretty quickly. The first one is called exponential growth. Exponential growth. Now, with exponential growth, this is when the population will reproduce and increase at a constant rate, not by a constant amount. We're not saying that each reproductive cycle that the population is going to grow by 5 individuals. What we might be saying is that it's going to grow each time by doubling. Now, when we say by doubling, a lot of times this is what I tend to see from students. All right, so if it's doubling, you start off with 1, then it becomes 2, then 4, then 6, then 8, then 10. That's not doubling. That's adding 2. That's adding 2 new individuals each time. What I mean by doubling, 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, 16 becomes 32, 32 becomes 64. So essentially what you do is you multiply each number by 2, not add 2. Because you're saying you start off with 1, divides, become 2. These 2 divide, become 4, then 8, 16, etc. So we tend to see this kind of growth in situations where the what was I saying? These kind of situations where the resources appear unlimited. Since the resources appear unlimited, there's nothing to really hinder the growth, so they just keep going and going and going. So you're going to see this sharp curve upward. So that's what exponential growth is. Now, is there any way that resources are unlimited? No. Like I said, this is when resources appear unlimited. So that might mean if we're talking about bacteria, because bacteria are known for exponential growth, when they're in a little petri dish and you're culturing them, to one bacteria cell, that is unlimited resources, because there's no way one bacteria cell can ever use up all that amount of that amount of resources, the nutrients, the space. So for that one cell, it seems unlimited. And as it goes and starts exponentially growing from 1 to 2, 2 to 4, 4 to 8, 8, 16, 32, 64, 128, etc. But as it goes through that, even at 128 individuals, that whole big agar plate still seems unlimited. So it's going to keep growing at an exponential rate. However, at some point, there's going to be so many bacteria cells in that petri dish that there's no longer enough room, and there are no longer enough resources and nutrients for all the cells to supply and provide for all the cells. So at that point, what you would notice is what we call a population crash. And it's very common for population crashes to occur after periods of exponential growth. And what that means is essentially it'll come up here and then a sharp drop down, maybe something like this. And then kind of starts growing again. So exponential growth is reproduction at a constant rate. Now, the other one, which is more likely to occur, is called logistic growth. Yeah. Logistic growth. There we go. So what logistic growth is, and this is what will actually occur in most populations. It'll start off like exponential growth. So it'll start off the same. However, at some point, the growth rate will slow down and it'll actually plateau off. So let me try drawing this a little bit better. There you go. So notice the bottom half looks a lot like exponential growth, but there's usually a point where the rate of reproduction slows down. So the rate of growth will slow down. Maybe it starts off as doubling, but then it changes and it becomes something different and it becomes more consistent. Now, you notice how it'll level off at some point. We call this the carrying capacity. Carrying capacity. And what the carrying capacity is the maximum number of individuals that an environment can support. So instead of, as we saw with exponential growth, going way past the carrying capacity, which means that there's a lot more individuals than can be supported, which will then lead to a population crash, the population stabilizes at or around the carrying capacity. So that maintains the maximum number of individuals that can easily survive and thrive there. Now, that doesn't mean that the population doesn't change. It doesn't mean that you aren't having any new individuals born. What it means is the number of births or immigration is going to be roughly equal to the number of deaths and emigration. So if you have 5 individuals born, you might have 4 or 5 that die. So it's going to be roughly equal. So there's not really a big change to the growth. Again, we're not saying that nothing's dying. We're not saying that there aren't any births. We're saying that the increase is going to be roughly equal to the decrease. All right. So yeah. Now, is it necessarily going to be exactly straight like that? No. A lot of times what will actually happen, what's more common, is going to be something like this. It'll kind of go up, down, around that carrying capacity line. So maybe have just a few more individuals that then can be supported in the environment. It causes, a little bit more death the next year because of starvation. But now we have less individuals than can be supported. So, we have a slightly higher birth rate and up and down, all around that carrying capacity line. All right. I hope that helped. I hope this was informative. And until next time, you guys, stay awesome. All right, you guys. Bye-bye.